Hey everybody, and welcome back to Radical Slice. My name is Eric. In this installment, we are going to be building a parser for our level data, or at least a part of our level data. I really like writing parsers. I think they're cool as heck, and so I was really happy to work on this part of the project. In addition, we'll also be building out some of our level info in this one. So yeah, let's hand it back to slightly under caffeinated early morning Eric from not too long ago. All right, well, it's early here, and I'm barely done with my cup of coffee. But let's talk about parsers. So the reason I want to talk about parsers is because I need to work on the level structure. And there are a couple ways we can do levels. Probably the most straightforward way is just to define some data structure. So you might have get the right brush here. You might have some list called levels, and then in that list you'll have some elements. Actually, that's not a list thing. There we go. You might have some elements that describe what's in there. So you might have like some baddies like this, and you'd have a list of baddies. And you might give the boss some parameters. Actually, I guess these would be colons. Let's say we have a boss object. You might also have some other properties like a length or whatever, and you just kind of define this directly in your code. This is all well and good, but given that Pico-8 has like some pretty strict limitations on the number of tokens that you can use in your code, I have found it is more efficient in terms of token use and also a lot more fun to just write a parser. I kind of got this idea from the Lazy Devs series of videos on YouTube, where Christian describes the Forsyth Edwards format for chess games. I'll link to that in the description. You should definitely check out the Lazy Devs channel and Forsyth Edwards on Wikipedia to get an idea for what we're doing here. But in any case, rather than defining the level structure directly as like some sort of data structure in code, what we can do instead is just use one string, which will basically be like, I think, one token in Pico-8, to kind of stuff all the information about the level into that one string. And then we'll just write a parser to interpret that. With only two levels, like we're doing here, it might not be super token efficient because the parser itself is going to need some code to handle it. But I think in the long term, it'd save you tokens. And anyway, parsers are great. You should write them all the time. So for our levels, we were saying that the levels might contain some baddies, and we want the baddies to appear at certain points, like when the player reaches certain distances. So let's say, for example, when the player reaches meter, I don't know, 50, we want to spawn one tree. So we might do something like 50, and then some sort of delimiter like a colon, and then the number of baddies that we want to spawn, and then like the baddie type, like that. And that would be one entry in the level. And then let's say we might have some other delimiter like, I guess we just keep using colon. We'll say at meter 100, we want to spawn two trees and one flower. So we would write 100, and then our delimiter and two trees and one flower. And we just go on and on like this, and we just define where the baddies appear in a list like that. We may also include some information here about the boss or about some other aspects of it. The more stuff, not surprisingly, that you try to cram into the string, the more complicated that your parser will get. So we may begin by just defining like how the baddies should appear and go from there. But yeah, I mean, I think this is a good start, at least to get our baddie stuff defined. So let me get started writing the parser now. So parser works pretty well. So let me jump back to Paint real quick to make a note. I realized after I started working on it that I had left one thing out. So we had initially said that we would define the parser entries as the number of baddies and then some delimiter. I'm sorry, the distance at which the baddies would spawn, and then some delimiter, and then the number and types of baddies like this. And then that would be the end of the entry. But I forgot that we also needed direction. So the direction could either be approaching from the left or from the right. So I included a third element here that would just be, 1 or 0, depending if it was left or right. And then we separate each entry by a semicolon. So it would kind of look like this. And so on and so forth. So let me show you how that looks like in code. Okay, so here's like what the level format looks like as a string. So in this case, and again, because I haven't mentioned this in a few hours, so we're moving from right to left, so the distance values decrease. So if we want to see the baddies appear in order, we would start with like a high value for distance and move to a lower value as the player moves from right to left. So at distance 200, we're going to spawn a single flower, and it approaches from side 1, which is from the left-hand side of the screen. Then at 150, we'll spawn one more, also from the left-hand side of the screen. And then finally, at distance 100, we'll spawn 2 trees and 1 flower from the right-hand side of the screen. So the way that this looks when we parse it, I'm taking heavy advantage of Pico-8's split function. This is a pretty common function in most modern languages. And what you do is you give it a string and some sort of delimiter, and it'll blow the string apart into pieces that you can then iterate over. So when we pass it this semicolon here, this is going to break up this big string by semicolons. So it'll kind of start by like removing this and giving us this, and then removing this and giving us this, and it gives us back a table, which is an iterable structure, so we can just kind of loop over it, right? Then we also further split that each individual value. So let me split this up here so I show you how it looks. So we're going to loop over each of these 3 batches. We're going to actually split them again by removing the semicolon. So now we have 3 separate values: the distance, the baddie data, and the direction that they're going to spawn in. So we set up like a local value to store all that. We also do a quick check here. We make sure that we should have 3 values, right? We would expect to see the distance, the number of values, and the number of baddies and the direction. And if we don't have those 3 values, we'll just crash, because like we can't interpret the level that way. We'll set the distance to the first value, and I'm just using toNum here to convert from a string to an integer. We'll also look at the baddie count and the baddie type, and then we'll add whatever that baddie is, whether it's a tree or a flower, into mybatch.baddies. So if you can remember, like, I think we can actually see this still. Hold up. Yeah, here when we want to spawn baddies, we just pass in this list of strings, the flower, 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 or tree, flower, tree, or whatever. That's what we're going to end up with in this mybatch.baddies, right? So mybatch.baddies is going to be like something like this. Like that, right? When we're all done parsing it. And then finally, we'll set the direction, and then we'll throw this mybatch into our big batches thing. And that's what we're going to return here. We're going to return a table value that's just a list of these sort of baddie batch definitions. And you can see I was doing quite a bit of debugging. If you're an eagle-eyed viewer or programmer, you probably saw me frantically typing print H statements into my editor, trying to debug some of these problems, because parsers can be a little bit finicky depending on the language that you're in and the parsing library you're using. In this case, we're not using any parsing library, so it's quite finicky. Okay, so what that results in is, an error. Hold on. Okay, so what this is going to look like is you can see up in the upper right-hand corner, I do have the map X value listed, so you can see as the player moves that we would expect the first baddies to show up at 200. And there's our first guy right there. So that worked as expected. He showed up in the right direction. And one thing that I was sort of struggling with was, actually, let me just play and hopefully we can see it. As the player is walking towards this fella, the player's velocity should actually impact the baddie's velocity. So we put this restriction on the player that as they're walking to the left, they can't get past the midpoint of the screen. But if the baddie sort of is unaware of that velocity change, it doesn't really make visual sense, right? We need to sort of compensate the baddie's visual position or the baddie's visual speed based on the way the player moves. So let me spawn this fella in, and then I'll try to run away from him so you can see what I mean. So he's moving towards me and I want to run away, right? Like that. So what I ended up doing there was just passing the player's velocity into the baddie's update function as sort of like a compensatory value. So if the player is like in this zone in the middle of the screen where they are only controlling the scrolling of the ground and not their own position, then we just pass in the player's velocity to subtract from, I think it ended up being subtract from the baddie's velocity so that it looks natural when the player tries to run away. So it's hard to see on this one, but it's a lot more obvious on this guy right here, right, as we run away. And you can see that after the player sort of reaches the point where they are free of the middle of the screen and they can move to the right again, you can see how the baddie starts to like catch up again like that. So visually this makes a lot more sense, but that was like kind of a struggle to get through that. So anyway, we did say we added 3 batches of baddies to this. There's the first one at 200, the next one at 150, and then as we reach 100, we should expect to see 2 trees and 1 flower approaching from the right-hand side. So let's make sure that that works. So there's 100 and here they come. Oh, there's 2 trees, but not a flower. So I think I got to go back and check something. We're missing something here. Hold on a minute. Okay, I see what it is. When I was doing some refactoring in the parser, I removed one of the loops that I had. So I'm only looking at the first values in the string for the baddie types. So in this case, I'm kind of looking at this 2t part and then just giving up. So I just got to go in and add some extra loop here, and that'll cover the flower, hopefully. Okay, so I fixed that looping error that I was mentioning before. And in order to make testing a little bit easier, I put the 2 trees and 1 flower right at the front at distance 200. So we should be able to see them show up right away. So if I restart here, you'll see them appear from the left. There we go. And they behave the way we want in terms of velocity, things like that. Let's take them out real quick. So yeah, and as we reach 150, we should see the next enemy. And finally, as we reach 100, we'll get the batch from the right. And you saw just for a moment, they sort of appeared a little bit slowly because I was walking away from them. So that like little distance trick that I was doing to add the player's velocity was working. So yeah, it isn't until I get free of the middle of the screen where they kind of reach their full velocity, which is exactly what I want to see. I mean, I want to say it's like more realistic. There's nothing realistic about trees like running towards you. But that looks game-like anyway. So that's pretty much it for the levels. We haven't done bosses yet. In fact, let's open the spreadsheet and see where we're at. Okay, we're actually looking pretty good here. So we know the hero, player, whatever, has health now. That's good. Baddies can damage the player. That's good. We just made a level format. That's looking pretty good. More than one. We haven't done the level changes yet, so we'll have to add that. And also I want to put this in like reset on player death. Right now we don't have that capability. We just kind of crash the game when the player dies. So that's like kind of a new requirement. So it looks like the next thing is maybe we'll keep going through the level bits. We'll make it so that the player can clear one level and then begin the next one, and also that the levels will reset when the player dies, and then we'll tackle the bosses. So in order to finish off the stuff that we'll need for the levels, I think the first thing I can probably tackle is just resetting on the player death. So we'll need some sort of reset level functionality. And rather than more than one, like probably want to rephrase this as like levels can be cleared. Like, because that's kind of more, that's closer to the actual functionality that I need to put in there. I think that's it. So let me just think about what needs to happen. Let's do player death first. I think that'll be a little bit easier to wrap our heads around. So a few things need to happen here. Probably need to like reparse the level, reset the player, and I think we have a reset method on the player already. It's probably out of date. I'll need to update that. And also reset the baddie manager. Since when the player dies, there'll already be some baddies loaded, presumably. So we'll need to kind of get rid of those so that we can restart the level. So let me dive into some code. Okay, let's look at some code. I made a few changes. So in main, I added this level index value, which is just going to be, the current level that we're on. Right now there's only one, but we'll need to switch that around later. And then in our init function, so when the cartridge boots up, I'm doing the parse level and I'm passing in that global level index thing. And that's going to dump all the baddie batches into this batches variable here. Currently, like the only thing we have defined in our level struct is really the baddies. So I think it makes sense to not call it level, but just call it batches for now. Maybe I should just have this be parse batches, but whatever. And then if we have a look at where the reset stuff happens, get rid of that. So I'm checking in the main game loop if the player's health is less than or equal to 0, which indicates that they would have died. And we call reset on the player, reset on the baddie manager, and we do the same parsing level. So that resets our batches. Having a look at the baddie manager reset first, because it's quite simple. I'm just resetting the baddies table to be empty, right? So that any baddies that respond when the player has died will just disappear. And then the player's reset function is a little bit more interesting. So I ended up moving a lot of those initial values for the player, that like they start off standing, they're facing to the left, etc., etc. I had those kind of defined as top level properties in this struct here, but I ended up putting them in reset instead, because player reset is like the first thing we call, almost the first thing we call in the cartridge init, right? So this is going to happen every single time the game boots up and when the player dies. So I think it makes sense to sort of consolidate all of the initial values into one function. Otherwise, I would have them duplicated in this top part and in the reset function, and that would be annoying after a while. I also made a couple of small tweaks in here. So the player's health, where I'm decrementing that when they take damage, I switched to using a max function because there's some possibility that this could end up being negative, and I didn't want that to happen. So by adding max, what I'm doing is just ensuring that it'll be always at least 0. Similarly, you may remember that we're sort of adding or subtracting, really, the player's velocity to the baddie velocity if the player isn't stuck in the middle of the screen when they're being drawn, to sort of simulate like how we would expect the baddie's velocity to change. I had previously just had this hard-coded to 64, but I realized that just due to some fractional positioning, the player could be, like not at 64. They could be like 63. I don't think they ever hit 65, but just as an extra caution. So I'm giving them a 2-pixel window here, or I guess a 3-pixel window, and using that to determine if we should adjust the baddie velocity. I noticed that like in some cases, I would, not always, but if I turned to the right and moved towards some baddies that were also coming from the right, that the velocity sort of adjustment wasn't triggering and things were looking kind of weird. So yeah, this kind of handles the death stuff. So if we restart the game here and start our journey to the left, let me just take out this first batch here. We'll let the flower take us out. So what we should see is when the player's health reaches 0, we jump back to the beginning of the level and all of our initial values are reset. So if we start our journey again, we'll fight the same initial batch of baddies. our nemesis, the flower, will be there. And we can continue all the way to the end like this. Okay. So yeah, I think so as you can see, when we reach the end of the level, there's no like nothing happens. So a couple of things I guess need to happen here. One is if there are no levels left, we want some sort of victory screen. But if there are levels left, we want to jump to the next level. So the victory screen is the easier part of that, right? We can just check the length of our levels struct and see if there are any more. And if not, then we'll end the game with the victory message. But if there are, we'll advance to the next screen. So the next thing, because it's kind of low-hanging fruit, I think, is to just handle the victory condition. So let me turn towards code and take care of that now. I'm realizing now that I never set up the sort of abstraction where I use function aliases to do the draw and updates so that I can switch this out. So what I'm going to do is just switch from having everything directly in draw to having like a game draw. And similarly, rather than having everything write an update, I'll have a game update, and then I'll just call those. So let me just take care of that now. Okay, that didn't take very long, but just to show you in case you've never seen this technique done before, it's possible that we might not always want to be drawing the game stuff to the screen. We might want a title screen or a game over screen. And similarly, we might not always want the current update loop to be the update loop on those other screens, right? It doesn't make sense to have the same game update logic on the title screen as it does when the player is actually, fighting dudes. So what we do is we add just like a layer of abstraction here, rather than putting all of our stuff in these Pico-8 defaults, these update and draw, which are called automatically. We can just set up a couple of quick function aliases with a double underscore. And we'll have our game update and our game draw functions. And in our init, we'll set our double underscore, our sort of function aliases, to game update and game draw. And then in the Pico-8 defaults, in draw and in update, we'll call, rather than calling game update and game draw, we'll just call these aliases. And what this allows us to do is, let's say like there was some other time where we wanted to display the title screen, we can just set draw to, title draw, and update to title update. And then when Pico-8 calls its default functions, rather than calling the game stuff, we'll call the title screen stuff. And that gives us a lot more flexibility in what we're drawing to the screen and what our logic is doing. All right, so now that I've done that, let me go ahead and add that victory screen. All right, that wasn't so bad. You probably saw that while I was playing at super fast speed, but yeah, as we work our way through the level here, when the player reaches the map x value of 0, which would be like the end of the map, oh, those guys are tough. The game will just switch to displaying the victory screen, and it'll soft lock at that point. So a couple things that maybe we can target for improvements later is, right now the player has to reach all the way to map x of 0. Maybe we want to give a little bit of a range there. And also, like, that ain't very pretty. So maybe when we get to the fancying up phase, we'll make this look a little bit nicer, or we'll have like a way to go back to the start of the game. All right, now I think it makes sense to add our next level. And one thing about Kung Fu that I kind of want to replicate, but what will require a few quick changes, is that the levels sort of alternate in terms of the direction that you're supposed to travel. So the player may travel from right to left, and then the next level they'll travel from left to right, which is like a small thing, but it kind of feels like you're progressing, even though the background is identical. So that's probably valuable for us too, right? Because our background is, as of now, not going to change at all. So that'll change a few things. One is obviously that thing we just did where when the player reaches map x of 0, that's when the level ends. that value is not necessarily going to be 0. It's going to depend on the direction of the level. All right, so I think probably I'll have to alter the level struct to include some sort of information about the direction of the level in addition to the baddie batches, and also change the detection of when the player reaches a certain map X value to finish up the map. So let me get cracking on that. Okay, as planned, I did beef up the sort of level structure. So whereas previously we just had a string here, I changed that to be for the batches, because it kind of makes more sense because it's really just determining when the enemies spawn. And I added a direction property too. So the direction is the same as basically it's the direction that the player will spawn facing, the direction of the player's travel. All right, so 0 would be from right to left, 1 would be from left to right. And then in main, oh, and also I changed from parse level to parse batches because it just made more sense, like linguistically. And then in here, let me go to the init function. So yeah, I have this sort of global level object here, which is just going to represent our current level. And when we init the cartridge, when we start things off, we'll parse batches for the current levels batches and throw that into level. And we'll also set the direction here. And also when we call player.reset, which kind of like initializes the player, we have to pass in the level direction because we need to know what side of the screen to spawn the player on and what their map X value is going to be and what direction they're going to be facing. So we're sort of using the value from the levels direction to determine some elements of the player's attributes. Similarly, a couple of changes to main. So we need to know if the player is going to reach or when the players reach the end of the level, which is going to be different depending on if they're going from right to left or left to right. So rather than just using, before I was kind of like, let's see if we can be the diff here. Before, you can see up in the top here, I was just doing like a straight comparison of the player's map X if it's less than or equal to 0. But that only works in one direction. So instead, I've switched to this isLevelEnd function. And you can see that I'm passing in the player's map X and also the direction of that level. And what that looks like in code is actually quite simple. We're just seeing if the level's direction is like this and the player's X value is this, then return true in this case. But if it's the level's direction is the other way, then we use a different sort of value. This map extent value is defined in the player file. And it's sort of just like kind of like this random global that I'm not super comfortable having, but it just kind of represents the maximum length of a full map. I'll probably have to do something about that later. But yeah, for our purposes, this isLevelEnd function allows us to consider the direction of the player's travel when deciding whether or not they've finished the level. Similarly, the other thing that was sort of dependent on player's position is when we spawn the enemies. And same thing here. I was doing, if the player's map position is less than the distance defined for that batch, the spawning location. But again, that only works in one direction. So I did the same thing here. I created this should spawn batch function. And it's very, very similar to isLevelEnd, right? It's basically just like if the direction is like this and the player's X has this relationship to the batch's X, then spawn, otherwise don't. And that worked out pretty well after some interesting bugs. So we just see if we're walking right to left, everything, basically we wouldn't expect to see any new behavior here. Everything should work just as it has been working. Boop, boop, boop. Oh, okay, there we go. And that allows us to finish the level. So now I'm going to add one more level and see if we can get this level clear condition to move us to the next level rather than displaying the victory screen. Okay, that wasn't too bad. And we've got multiple levels working, so let's just have a quick look here. I'll speed this part up so you can just watch me play up towards the end. It's worth noting that I didn't actually have to kill those last guys. I could have just walked to the edge of the screen, just like the original. So you'll see when I get to the end here, it'll just jump real quick. There we go. So it might have been really hard to notice, but we're on level 2 now. And you might have seen for a second there, because I was holding left when I walked to the end of level 1, the player was automatically walking left because I was still depressing the button when I got to the end of the level. I'll probably want to do something about that. In the final version, I might just have like a, like a stop the world, like level 2 type of message pop up. But given that I also want to fix this like machine gun punch thing where you can just hold down the button and he'll punch endlessly, that's like a similar problem. Like I just want to block player input until some condition is met. So I'll probably have to address that. Anyway, let me play the second level really quickly. Okay, and you'll see when we get to the right end of the screen here, because there are no more levels left, because we've only defined these 2 levels. When we reach the right edge of the screen, we'll get the victory message, and we're done. Okay, so let's have a look at our checklist. So now we know that levels can be cleared, and we know that levels will reset when the player dies. So I think levels are pretty much good. The next big thing that I can see here is going to be the boss stuff, which is going to be a pretty big undertaking. So let me think a little bit about how to tackle that before we get started. All right, thank you all for watching. I hope you enjoyed that. If you did, feel free to click, the little thumbs up button or the subscribe button if you're into that. There's going to be a lot more of this stuff on the way. I also want to take this opportunity to just give a shout out, because I haven't done that yet, to the musicians who have their music up on the YouTube audio library page. I don't know if they like volunteered for that or if their license is just permissive enough that YouTube can put that stuff up there. But either way, I appreciate that. So the artists that I've used so far have been Dyalla, Cheel, Single Friend, Bail Bonds, who else? And Bad Snacks. So this episode, I think I used exclusively Bad Snacks' music. So definitely give all those channel pages a look. If you get a chance, I'll link them in the description. And yeah, next time I think we're going to be working on the boss stuff. So stay tuned and bye for now.